So this is going to be a much abridged version of the talk yesterday, where I shared a little bit about my work, the way that I wield technology and design to make visions of the future that I would like to see in the world. And so I shared a lot about animacy and agency and how design can impact robotics. So I've built up a bit of a career traveling the world, taming these big beasts of machines to, instead of doing short, repetitive tasks over and over and over again, to really be improvisational and free and kind. And I use my training as an architect and all of the hypersensitivities to what I have to how people move through space. And by learning how to program machines, I was able to give those sensibilities to these machines. So for me, I feel a little bit of an outsider in the world of robotics. I feel a little bit of an outsider of the world of architecture and design, because I do my best to really blend these two things. And for me as well, it's important that the people who are trained to work with the humanities, to create new culture, to be deeply embedded in how technology comes to shape that. So we've really started off by starting to question what is a robot. And we have a lot of pop culture references in our mind. When we close our eyes and we think of a robot, we might think of these humanoid things like Osimo or C-3PO or these Boston Dynamics Atlas robots. But I find it much more productive to think of a robot as anything with a mechanical mind and mechanical muscles. And with that broader definition, you can start to see that there's many robots already around us, living amongst us, from industrial robots that I tend to work with, to self-driving vehicles, delivery drones, to in hospitals, robots that deliver towels and medicines from a central resource area to individual patients, to our toys, and even our 3D printers are a form of a robot. Washing machines, very dumb, but also a type of robot. What I love about working with industrial robots in particular is that these are big, giant machines that have superhuman speed and superhuman endurance, precision, and reliability, and yet they're locked away in these factories doing very boring tasks, living very boring lives. And they're also this symbol that we have in our culture that carries our fear of our own obsolescence, that this technology could replace us. And these machines in particular are a vessel for that, but it's kind of how we feel about artificial intelligence, both software and hardware. We have this anxiety about the technology that's coming our way. One thing that I find quite interesting is that the birth of robotics in industry, this is the Unimate robot arm from the early 1970s, was really being explored at the same time by engineers inventing new machines for art purposes. On the left is an exhibition from Cybernetic Serendipity a couple years earlier. And I feel that for some reason, we got stuck on the timeline where these machines needed to be efficient and optimized and repetitive. And I really want to get back on the timeline where these machines were curious, kind, and alive. And so that's the work that, with the same set of skills, with the same machines, that's the world that I try to make with my work. And so this was an installation in the Design Museum in London. And this is Mimis. She usually lives on a factory assembly line in Birmingham in the UK. And the manufacturer was kind enough to let Mimis come and live in the museum for 6 months and have a bit of a holiday. And so she got to put down her tool and really just live and exist here. And so I created a software system, an interaction design system, and a sensing system for her to be able to see the crowd of people, pick out who might be the most interesting, and go hang out with them for a bit. And when they were too boring, she was allowed to just get bored and go find someone else to play with. And what I loved about taking this work out of academic research and out of industry and bringing it into cultural institutions is that now 100,000 people over the course of 6 months have an opportunity to engage with technology in a way that gets them to think about their own perspectives and develop their own opinions about what our future with these machines should be. Too often, we think that technology, the most probable route of technology, is the way that it must be. But we have a lot of agency in guiding the direction of how rapidly advancing technology intersects with society. And designers, I think, play a frontline role in deciding that. I believe that designers can create technology. The tools and education that we have is becoming way more accessible. From what we've seen from a lot of, like what we'll see from Yusuf later as well, is that these AI-powered tools can also be used for learning, for our skills to stay relevant longer in our career and to learn new things faster. And so the work that I do works on top of open source hardware and open source software to both build on top of these creative coding communities and also give that knowledge back so no one else has to go do a PhD to learn all this stuff. And so Mimes was a way to get one robot to interact with a crowd of people. And because of that, the World Economic Forum invited me to explore what is the future like when we're surrounded by these machines. If their vision for Industry 4.0 really comes true, now all of a sudden, they'll be all around us and amongst us, and what might that look like? And so for me, I built these robots that what we don't think about these machines is that unlike us, where we begin to perceive and feel and think about the world with our own body, these 10 machines have one central brain, and their senses are distributed in the space around them. So they're like a hive entity, and their behaviors can reflect and reverberate amongst each other. So here's a little bit of how they look and seem. These are all tools that again, I built in the simulation software that I think, especially from designers who are very familiar with computer-aided design or computer-aided manufacturing, there's a really easy bridge to begin to use that to make machines move and to make machines think through geometry. And what I've found from this work is that these machines that don't look like us and don't act like us and don't think like us, that if we begin to make them move in a certain way, we can shift from a metaphor of control to more of a metaphor of connection. And that's, I think, a more apt relationship that we're heading towards as these machines get smarter, as they get more autonomous, as they get more independence and intelligence. And so a lot of my work, I try to be inspired by the natural world. I see these machines not as automation infrastructure, but as mechanical creatures in this robotic ecosystem that's living amongst us. And I had the opportunity about 2 years ago in Zurich to come and be living inside this factory for robotic architecture and retrain their machines to behave more like a flock of swans than a tool for assembling pavilions. And it was a really delightful experience to begin to work with them. And simulation technology is really at the core of what I do. A lot of what I have been able to do is also, this is a sensor that's picking up my body. And so I'm able to translate my understanding of space and how our bodies relate to each other in space and feed that knowledge to a robot. And that would not have been possible without an architectural education. That would not have been possible today in how robotics and how machine learning and AI is taught in there, because it's such a wealth of domain knowledge that you have to have through deep education in design, in the arts, in the humanities. And so hopefully in the future we can begin to merge these educations together. I also believe in I am really lucky. I have amazing friends that have fun toys. And so my friends here just got, this is the world's biggest robot. It weighs 5,000 kilograms. And so we decided to put a big giant googly eye on the end of it. And what I wanted to really explore here is just how little information our minds need to see life in inanimate objects. So it's a black circle on a white circle, and all of a sudden, you get it to move a certain way, you get its motors to roar, and it starts to really come alive. And I see this as such a powerful material that designers know this. Designers know that a couple subtle, intentional gestures can transform meaning and make connection. And we can begin to put this into physical systems that are alive with us. And lastly, I shared some creative practitioners that I am really inspired by and that are also really pushing at the fringes of how the arts and robotics begin to intersect with society. So this is from Golan Levin, who is a mentor of mine from the Studio for Creative Inquiry at Carnegie Mellon University. And this is a robotic worm eyeball googly eye that we have a tradition in the studio to put eyeballs on lots of things that come in. Random International is a UK-based creative studio that is making living mechanical creatures like these drones that they respond to the people going below them. This was developed for a dance troupe, a performing arts troupe, to begin to have choreography below and choreography above. And so the relationship between set design and performance arts is really changing. I think that robots don't even really need to have digital brains. They can have intelligence built into the material system. These are a bunch of toilet plungers attached together that are pushed through a minefield to detonate mines. The intelligence is built into the material system, and it serves its own purpose. And similarly with Theo Jansen, with his strand beasts that again use wind, use water to wander the shorelines. There are lots of, this is some good friends who are very talented artists and designers exploring robots as creatures and also using robots for non-industrial purpose. That's the mission of their studio, art studio, is to reuse these machines for non-industrial purposes. Soo-Win Chung is a brilliant visual artist, performing artist, who collaborates with her own troupe of machines. What's lovely about this is that Soo-Win is inspired by how the machines are moving, and the machines are taking in data from whatever city she's performing in and using that to inform their own pathway through the drawing. Adi Wagenknecht, who's an artist based in Austria, not too far from here actually, did this portraiture, very traditional form of blue chip artwork, but she's doing this portraiture around her body, letting a robot vacuum begin to paint around her, showing sort of the absence of female bodies in art. Robots can be entire environments, so this is just using light and robotics lights and a bit of fancy fog machines to really begin to bring an entire atmosphere to light. And these machines can also live beyond the extent of their body, like this robot that shoots clay pellets to build giant cavernous caves in Zurich. And there's also an entire community of architects now that are building purpose-built, one-use specific machines to make their own structures. So this is my friend Maria Jablonina, based out of University of Toronto. And she built a series of robots that begin to weave and pass cable amongst each other to autonomously build their own web of space. So we're living at a very exciting time for designers, architects, artists to really take the helm and provide leadership in how this technology comes into touch the physical world. And we left the workshop with a prompt, with a question: what if all the things in our life were animate and alive? And so we broke into groups and had a little bit of a prompt thinking about starting with a thing, like a table, a lamp, a bed, a door, a shoe, giving it a personality, and then building a narrative around that. So a table that is maybe a little bit vain might not want water put on it without a coaster. So it would begin to dip and move and throw the water off to protect itself. And then we discussed some of the practical applications that could hold. So it was a quick exercise, but again, starting to think about this world that we're racing to, that everything can be alive. With a $4 computer chip, you can have something that is connected to the internet. It's very accessible, that we're literally getting to a point where everything can be connected and alive. And hopefully we can build the technology in the way that we would like it to be, and not the way that it's coming towards us currently. Thank you.